In this video we'll take a closer look at the CTL solving and generation capabilities of LogiVis. We've already had a similar introduction to Boolean algebra, so to simplification of formulas, getting singular and all available models for a formula, and parenthesizing them, as well as generating Boolean formulas. If we now go ahead and up here in this toolbar select CTL, we can see that the buttons that are available to us change, and only a single button remains, which is called check model. And this is the main feature, or main CTL, computational tree logic feature of LogiVis, that it can evaluate if a CTL formula is satisfied by the states of a given model. And therefore everything we need is a Kripke structure and of course a CTL formula. When selecting the CTL option up here, the formula generator on the right here, that you have already been given an introduction to, knows that the generation target is now CTL. So if we go ahead and generate a formula, we can see that we're now getting CTL formulas. If we now go ahead and also generate a model, so a random Kripke structure with 4 states and 3 properties, then we can go ahead and check the model, and we can see that we have been given a result from the CTL solver running in the background, in the form of a state list that tells us that all 4 states satisfy the given formula. Down here we can see the solver trace, which tells us how the CTL solver approaches solving the given formula. So we can see here for every model state which is satisfiability of this expression here, and it for instance starts by finding the outermost expression, which in this case is the OR here. Then it goes ahead and just evaluates the formula for every model state, and we can see that this formula, even though it looks a bit complicated, but it's actually can be broken down to a very simple expression that it is satisfied by every single state. We can also change it to something which is a bit more straightforward. So here we just check for every state if there's one of the subsequent states, or one of the states that is reachable through a direct transition possesses property A, and we can see 2 states, so N0 and N2. The one of the subsequent states possesses property A, but for N1 and N3 this is not the case. Let's find N1 and N3. Yes, so as we can see here, for N1 we have only one outgoing transition, which goes to N0, and N0 has property A negated, so of course it does not have property A directly, and therefore for this state it's false. And this is basically it.